Next up, we're going to look at an interesting example of an infinite group, in particular, a subgroup of a really infinite group, the group of self-bijections of the real numbers. And the subgroup in question is not actually, as of yet, established to be a subgroup. That's the content of the exercise. We are going to prove that the family of functions, f(a)(b) of x, r to r, which sends x to ax plus b, is a subgroup of S of the real numbers. And in this video, I'm going to do the first two parts of this exercise. These two parts are asking us to verify that this is in fact a permutation for every a and b, and give the composition law. In other words, we know that we can compose linear functions and get a linear function, but if I compose an f(a)(b) with some other f(c)(d), that what is the rule for how that these things get related to each other? So without any further ado, let's get into it. So first off, we need to see that f(a)(b) is a bijection. Well, I neglected to tell you that I need to assume that a is not 0, otherwise it's not a bijection, right? If a is 0, this is a constant function, which is super not injective and super not surjective. So we insist on a being different from 0. Then, for injectivity, we need to see that f(a)(b) of x equals f(a)(b) of y implies x equals y. And of course, this is true because f(a)(b) of x is ax plus b, f(a)(b) of y is ay plus b. So I subtract b from both. And now, since a is not 0, I divide by a, and I get the thing that I wanted to prove, namely x equals y. For surjectivity, I'm going to cheat. Since a is not 0, this line has some non-zero slope. And so a non-zero line might look something like this. And, well, now my argument is, look at the pretty picture. More specifically, my argument is that since this line is not 0, however high up or down low you have to be, you can continue this line until you reach that arbitrary value, whatever it is. Maybe slightly more precisely, a little calculus. You have a positive infinity limit on one end, and a negative infinity limit on the other. Both of these are assuming that a is greater than 0. Otherwise, if a is less than 0, you have to switch them. But in either case, we've seen many times that when this happens, this function is surjective because it's continuous. Okay, so now that establishes that the f(a)(b)s are a bijection, which means that they are elements of this group SR. So let's work out the composition law. In other words, what do we get if we compose f(a)(b) following f(c)(d)? And all we got to do is plug everything in one by one. So let me write it this way. This is cx plus d. Right, just plug in x into f(c)(d). And now I plug this whole thing into f(a)(b). And I simplify this until it's of the form something x plus something. And then that tells me what the coefficients are, which is what I need to see. So this is acx plus ad plus b. And so the slope is simply ac, and the intercept is ad plus b. And so that's the rule. The rule is ab times cd becomes multiply ac, and then multiply and add in this other component. I think that's a little bit weird, a little bit counterintuitive. I'm not going to say too much more about this. In fact, we're going to wrap this video up here, but I will give a little hint about what's going on. For those of you guys who know linear algebra, Try expressing this formula with matrices. And then if you figure that out, you might get a little bit of an insight into kind of what's going on here and why. And with that, I'm going to leave the rest of this to you. So on your homework, we complete this exercise of determining this, or sorry, not determining, but proving that this is a subgroup. And so I've given you some sense of how these calculations go. You guys will take it from here.